Jupiter's mysterious moon Europa could change everything. Beneath its icy surface lies a global ocean, larger than all of Earth's oceans combined. Now imagine this: a probe pierces its icy crust and descends into those dark, unknown waters. Suddenly, it detects signs of life. Not simple microorganisms, but complex creatures, adapted to a world of eternal darkness, feeding on chemical compounds and surviving in an alien ecosystem that has evolved independently for billions of years. This discovery would not just be news, it would be the greatest discovery in human history. We would no longer be unique in the universe. The question of whether we are alone would no longer make sense, because Europa would prove that life can arise in the most extreme corners of the cosmos. But what would it mean to find alien life? Could we communicate with such life forms? What could they teach us about biology, evolution, and even the origins of life on Earth? And most disturbingly, if life can exist on Europa, what other worlds in our galaxy might be inhabited? This discovery would not only transform science, but also our culture, our philosophy, and our perception of the cosmos. Europa would be proof that life is not a miracle unique to our planet, but a force that could be pulsating in the depths of other worlds, waiting to be discovered. Are we prepared for what we would find? And what would it mean? The search for life on Europa is not just a scientific exploration, it is a look into the future and perhaps into the greatest secret in the universe, that we are not alone. Imagine for a moment that your eyes open to the unimaginable, that the reality you know unfolds before you like a cosmic tapestry. What if, suddenly, you could perceive not only the three dimensions that are familiar to us, height, width, and depth, but the fourth, that mysterious dimension of time that draws us inexorably into the future? And beyond that, what about the fifth, the sixth, even the 11th, or more, according to the boldest theories that challenge our understanding of the universe? The world as we know it would be transformed into a kaleidoscope of infinite possibilities, where space and time would no longer be the straight lines we think we understand. You would see objects intertwining and overlapping, existing in multiple places at once, like ghosts dancing in an impossible choreography. The past, present and future would unfold before you like an open book, with all its pages simultaneously visible, allowing you to observe the birth and death of stars, the development of civilizations, all in a single instant. You would witness parallel universes, each with its own history, its own physical laws, vibrating at different frequencies, as if they were infinite notes in a cosmic melody. The perception of reality would become so complex and overwhelming that our minds, accustomed to limited three-dimensional vision, would struggle to understand, like a fish trying to understand the ocean. Perhaps beauty and chaos would merge in a cosmic dance, revealing a truth that until now we could only intuit, that our existence is just a small note in the immense symphony of multidimensional reality, a tiny bubble in an ocean of dimensions that extend beyond our capacity to understand, a universe of universes waiting to be explored, if only with the imagination. Imagine a universe where antimatter is not a rarity, but a dominant force. Rather than representing a tiny fraction of existence, antimatter pervades entire galaxies, coexisting with matter in a cosmic dance of annihilation and creation. Planets made of antimatter orbit these antimatter suns, mirror worlds where everything is reversed. What would life be like on such a planet? Would life forms evolve based on antimolecules, distorted reflections of the biochemistry we know? But the real question is, what would happen if the matter and antimatter of these universes collided? The answer is an explosion of cosmic proportions, a release of energy so vast it would dwarf supernovae. Space-time itself would warp, creating unstable wormholes that would connect distant universes, or perhaps, tearing apart the fabric of reality. The resulting radiation would sterilize entire solar systems, transforming galaxies into cosmic wastelands. In our own universe, scientists have managed to create tiny amounts of antimatter in laboratories, demonstrating its destructive potential. But what secrets could antimatter reveal if we could study it in large quantities? Could we harness its energy to propel spaceships at speeds close to the speed of light, allowing us to reach the stars? Or would we discover new laws of physics, rewriting our understanding of the universe? The abundance of antimatter would not only transform the cosmos, but also challenge the limits of our imagination and knowledge. A universe dominated by antimatter is a universe of infinite possibilities, but also of unimaginable dangers.